Okay, we are in a discussion of AWS solutions architect, and we've been discussing about containerized services provided by AWS. Under that, we discuss ECS and EKS. Uh, Today, what we're going to discuss is we're going to start discussing about another important service uh, which is provided by AWS, which is called messaging service, right? Um, so let's first look into what is this messaging service and why it is important so much in nowadays in this messaging service in modern microservices decoupled services environment rather than monolithic service we've been using in the past, right? So what are the messaging service? So messaging service enable different software systems and in devices to communicate and exchange information across, right? So different programming language in the various platforms and distributed environment, right? So that is the major benefits because it's work with the different systems, right? And it is working with the very difficult, very different systems. Like I remember a long time ago when I work in one of the company, we've been using a network monitoring system. So network monitoring system, we use Nagios with the SMS sort of a modem plugged into the server, um, and then using a SIM card, we were able to send messages when the server failures and critical when our service goes critical. It sends our technicians message through SMS, and then when we get that SMS, we normally take action to restore that service which is having a critical condition or might be a service failure. But nowadays, it's not like that. So it's got a decoupled architecture, so enables a synchronous communication between applications and component, improving resilience and scalability, right? And that is the difference. Like it's not a one system. There are so many systems, right? They're all connected, interconnected, and then working as a whole system. Like say ordering system. When you're ordering a pizza, it might communicate in a very different ways. It communicate with the payments gateway and to getting a message your payment is successful, and then send the message into the kitchen, which you prepare the food in there. So and then when it's ready, it will send back a message to customer saying your food is ready, so you can go to counter and collect it. Or a lot of things are happening, right? So the other thing is facilitate seamless integration between a diverse system, regardless of their implementation technology. So it can interchange this communication in between different systems. So that is the major different in the past and nowadays the different, right? But let's go into the next slide. So mm, how messaging services address the modern cloud integration needs, right? So the messaging service enable loose coupling between applications, allowing independent development and deployment cycles. Application communicate through message queues, reduce direct dependencies between services, enable dependent independent scaling and update. So different system, you talk with a different system, right? To get the things working between different system, as I said, like you working with the banking system, you working with the customer system, you working with the kitchen system, right? And there might be work with the delivery system. So many different systems work together with this messaging and scalability. Like as I said, take an example like you ordering a pizza, work with the customer, and then it work with the payment system, and then work with the kitchen, and order is ready. So working with the Uber or some other delivery system. So many things work together with the messages. This is how these days modern cloud integration messaging service is really important, right? So scalability, dynamic scaling capability to handle various workload and traffic spikes, auto scaling based on queue depth. So messages are in a queue, so auto scaling will happen according to a queue depth to clear the queue, uh, providing actions for messages. So load balancing across consumers, horizontal scaling support, right? And asynchronous communication. I think synchronous real time, asynchronous, like it's not a real time, it's a bit of a delay, but I think I explained synchronous and asynchronous data while I was talking about RDS, right? So handle non-blocking operations efficiently through message-driven architecture, fire and forget message pattern. So you send a message and forget, so you're not getting a reply. Event-driven processing workflows, improved system responsiveness, right? Ensure reliability, so built-in fault tolerance and message durability features, right? Messages, persistence, and replication. Date letter queues for failed messages. We're going to talk about date letter queues and all other components when we're talking about each service descriptive in later slides in this video. So, guaranteed delivery mechanisms, right? So, let's see. I don't know whether it's clear, but this is a microservices architecture with a messaging service. I'm just going to mm, over in between them so you can see these ones. What is that mean? So the first one is the API gateway, application programming interface, and then you have different services in this color microservices, and then message queues, and then message broker and database, right? So if you're looking into this one, it's a user services, right? So user trying to do something, right? So this is the interface API gateway providing access, right? So here you got a user DB, right? In here you got a order DB, and then here you got a payment DB, and here you have notification DB. So this is like something ordering system works, right? And here the order service, right? Order service, order events queue, right? And then message broker, right? And then you have payment service here, and then payment event queue, and then here notification service, and then here notification queue. So you see that a lot of messaging services are integrated with the system to make sure the things are working right. Like let's say simple scenario, when you're ordering a pizza, you go online and then you place the order, and then it will go to payment system and will get back saying payment is successful, and then the order is sent to the kitchen, and then when the order is ready, that will send back a message, and then that message will send back into, if you're using a delivery service, so delivery guy can pick up, and then you delivery guy comes and delivered, then the company service provider will get possibly a message saying it's being delivered successfully or something like that, you know. So that is how these things are working together, right? Let me have a look. Previous one. Make sure, yeah, slide is finished. All right. So the evolving need for messaging in modern cloud architecture, right? So again, what I explained, so it says why point-to-point doesn't scale. So traditional integration approaches create tight coupling with complexity that doesn't work distributed cloud environment today, right? So payment system is somewhere, and user database is somewhere, the order database is somewhere, and these things are working together, everything. So because of this monoliths to microservices, right? So cloud computing has fundamentally transformed how we build applications. So earlier we built the application fully one application with every single feature in that application. So you usually select a platform. You want a Java, you use Java. You want to use .NET, you use in .NET, or you use programming something else like C++ or something. Uh, but today, uh, the traditional monolithic architecture have evolved into a distributed microservices because it can't satisfy monoliths, these sort of services with the modern environment, right? Uh, Single deployable unit become multiple independent services, and in process calls, network-based communication. Long time ago, we've been doing with these stuff with the call. You call like a Pizza Hut and order a pizza, right? And then they possibly give you a call back. Hey, your order is ready. You come and pick up. Today, everything comes into our smart mobile. So everything is ready, payment is done, and then the delivery is on the way. Everything coming into a network-based communication, right? And shared databases, services specific data stores. So um, we have a one single database handling these things, but today, so you have services specific data stores, right? It's a different one. Let's say even if you're using something for one database, like a user database, or uh, keeping a permanent one, and then the other one possibly be a temporary database or older database, might be a different system, faster system. Uh, so event-driven architecture emergence, right? So modern cloud applications require asynchronous communication pattern. Event-driven architecture enables services to react to state changes without tight coupling. So states real-time data processing, scalable event streaming, loosely coupled service interaction, right? So yeah, so here the microservices communication pattern comparison. So the point-to-point pattern. See that order services is linked to everything. Here the user, the old communication, right? See that order service, right? And then user service, notification service, shipping service, audit service, inventory service, analytics service, payment service. They all work together like connections, 18 connections in between them. So complexity is uh, in squared we call, right? But here the system's message broker pattern, centralized communication, right? See, everything is talking to this messaging system. So there's no direct communication in between the each service. So it's become easier for to usable in modern architecture, I think, right? All right, that's going to be all right. So AWS messaging service enable decoupled communication. So that's the different, right? So decoupled architecture is component communicate through intermediary messaging service rather than direct connections, enabling independent operation and deployment. Like see that things are use messaging, right? Once the payment is done, there's no direct connection between payment and the kitchen. So we'll send a message, hey, payment is done, you need to get this order ready. So that means kitchen got a message, right? Kitchen has to prepare the food, right? So that's something like that. And then that's when that is ready, we send a Uber Eats or something, all right, your order is ready to pick up, right? Uh, that's right. And the Uber driver possibly getting paid from another service, right? It's not directly related to a pizza delivery or pizza company, whatever is delivering, right? So that is saying enabling independent operation and deployment, right? Okay, so communication patterns, synchronous versus asynchronous. Synchronous real-time request responses, immediate feedback required. Asynchronous fire and forget messaging, right? Eventual consistency acceptable. It's not a really real-time, but you send and it is forget and it will get eventually. Uh, that is the difference between synchronous and asynchronous. Mostly using asynchronous communication in here. Uh, Key benefits improved scalability, scale component independently, right? It's not difficult to implement because if you want to talk to another provider with there's no any link between you, just you need to send a message to their system, and then their system will work accordingly, right? That's how it's work. We couldn't do that one like long time ago. We just need to write a program to talk to their uh, other program, something like that. So fault tolerance, failure, isolation prevent cascading issues. Independent deployment deploy services without affecting others. That's right. So I work with some other company, but I don't want to know what is happening in there. I just need to send a message, some message service setting. Hey, I need this one. So how do you make? I don't care, but it will happen and come back to me, right? So technology flexibility, mix different programming languages and frameworks. So long time ago, if you select something like .NET or Java, you have to use the same thing. Like in here, I don't know when I'm sending a message, you do have a .NET or Java. I don't care. I mean, it doesn't matter as long as my work is done, and that's all what I'm caring about. So, real world scenarios, e-commerce, order processing with inventory, payment, and shipping service. That's what I've been normally discussing. Video uploads triggering transcoding workflows, right? And then IoT system, right? Sensor data collects and analytics pipeline. So that is how things happening, right? All right. So we just discussed about these things. Even in a messaging concept, there are few different concept, right? So that's what we just going to talk, and then we're going to looking into we cases the services that getting into these different categories. So the going to talk about few core different messaging concepts. The first one is a point-to-point queue. So point-to-point queues is a direct communication between producer and consumer. So one message, one receiver, guaranteed delivery, order preservation, right? So user cases, order processing, task distribution, the load balancing. So that is point to point. You got here, and that's another point. So we sending a message there, one message, one receive, right? So, so publish, subscribe topic. So broadcasting message to multiple subscribers. The one-to-many communication, loose coupling, dynamic subscription. So you probably in your life you might have subscribed some of things like you sometimes when you are working in IT field, you sometimes subscribe to newsletters, so updates coming up. You subscribe, you get a program, right? You buy a program. Let's say you buy some sort of program, you make it music or something, and you probably subscribe their newsletters coming into your email that you can see what are the new happenings like technology updates, software updates, something like that, right? So it's a one-to-many communication and loose coupling, right? The dynamic subscription, you can subscribe, unsubscribe, so something like that, right? Then the event-driven architecture, reactive systems, so responding to state changes, right? So it's responding according to the message you sent to them. So that is asynchronous processing, right? The fire and forget type, event sourcing, microservices integration. So the public subscribe topics or notification, news feeds, and real-time updates, right? So user cases, CQRS, pattern, audit trails, and event stream, right? Um, so here you can see like always we get some graphs, right? So these graphs you can see point-to-point queues. So see that point-to-point one is a delivery guarantee, right? And then publish, subscribe topics that asynchronous normally. And then you can see event-driven one, right? Event-driven one's complexity is high, right? And then you can see coupling level, right? That's how message patterns comparison. All right. So as we do normally, right? So when to choose each messaging service, right? So let's looking into a little bit of different messaging systems here, and after that we will go back into that diagram decision tree, right? Before we go into decision tree, let's have a look what sort of messaging services provided by AWS. Okay, so the first one we provide is Amazon SQS, simple queue service, right? So volume, high throughput, up to 3000 messages per second is standard, unlimited dispatching. So that is simple queue service. You can do 3000 messages per second, right? And latency is low latency for message delivery and processing. So it's a faster service like a low latency, right? Integration. Simple setup with straightforward APIs and SDKs. So that means this service is easier to integrated with using application programming interface and software development kits, right? So that means you can use this service easily to integrate with your other deployment, right? Best for point-to-point messaging, decoupling microservices, reliable message queue, right? And this is the trailing SQS is basically very good for point-to-point messaging, whatever we discussed, decoupling microservices, right? And key features, the saying dead letter queues, right? We're going to talk about these features in next slides. Dead letter queues, which is failed messages, what we're going to do, failed messages and message visibility timeout, and FIFO ordering available, first in, first out ordering available, right? So I can use first in, first out. The messages go into the order is coming and goes first, right? If second one coming goes after the first one goes, like that, right? So first, it's like first come first service, like similar, right? Then you have Amazon SNS, simple notification service, right? So volume is a medium throughput optimized for pan out scenarios, right? Low latency for immediate message delivered to multiple subscribers. So the one to many integration, simple publication sub-model, right, with easy subscription management. Best for broadcasting notifications, mobile push notification, email, SMS, alerts, like you sending alerts to number of like subscribers, sending a message saying, all right, the new update will be out in next Monday or something like that. So key features, multiple protocol support, message filtering, cross-region replication. So that we calling SNS, Amazon SNS, right? So base for broadcasting notifications. The first one, SQS, is base for point to point. And then we got Amazon Event Bridge. So volume variable throughput is scale based on event pattern and rules, right? So latency, moderate latency due to event processing and rule evaluation. So it need to process some events and rules. So it not faster as whatever we discussed already. Moderate latency, right? And then integrations, a complex setup requiring event schemas, rules, and target configuration. So that is how the messaging is working is depend on the events happening. So it going to be a bit of a complex, right? Bespoke event-driven architecture, application integration, so serverless workflows, right? So key features, event or replay, custom event buzzers, schema registry, advanced routing is a bit of a complex because it works with the event, right? And then you got Amazon MQ. So volumes lower throughput compared to native AWS service. This is sort of like a legacy service type, right? Latency, ultra low latency for real-time messaging requirements, requirement. The complex setup but support the standard protocols. So these protocols are normally the protocols we've been using for messaging. So they are all messaging protocols. The first one is the JMS, we call Java Message Service, right? And then second one is the AMQP, Advanced Message Queuing Protocol, right? And then the third one is um, simple streaming text-oriented messaging protocol, text-based wire protocol, and then the other one is message queuing telemetry transport binary lightweight wire protocol, right? So I'm not going to explain these ones. You can have a look in you type in Google or somewhere, right? So this is the best for legacy system integration, enterprise messaging, protocol specific requirements. So key features to manage Apache, Active MQ, RabbitMQ, existing protocol support, and enterprise features, right? So, so in the message patterns point to point, if you want to select something as a point to point, you use SQS, simple queue service. The published subscribers use simple notification service. If it's an event driven, use event bridge. So legacy integration, use MSN MQ, right? And let's go and have a look now with this decision tree, right? Let me have a look. So this one is like a e-commerce scenario. So the before that, we'll discuss this one because it's a small area. Um, so order processing SQS for reliable queuing, right? Notification SNS for customer alerts, inventory events, event bridge for system coordination, and then financial services, first in, first out for order guarantee, risk alert, SNS for immediate notification, compliance event bridge for audit trails, and then gaming platform player action, SQS for high throughput, leatherboards, game leatherboards, SNS for real-time updates, uh, achievement events, event bridge for complex routing, right? Now let's go into these four different systems, right? So message requirement. So your volume is bigger than 100K per second, right? If it's yes, then go to SQS standard, right? And if you says volume is no less, then is it a multiple consumers? If it's a multiple consumer, no, and then it asks first in first out required. If first in first out required, yes, then SQS FIFO. And if first in first out not required, then you go to legacy protocol, right? Uh, Legacy protocol, if it's a legacy, you go to Amazon MQ. If it's not, it's go back again SQS standard, right? In here, it's for multiple consumers like publish or subscriber. Then it asks whether it is event routing or not. If it's an event, that goes to event bridge. If it's not an event based, then it goes to simple notification service, SNS, right? So that's how it's going to be in between these four different services, right? All right, let's go back again a little bit more explain the decision tree is here. So I start here, the message requirement high. Uh, this one it says more than 100K per day was low consumers. Then you select consumer, single consumer or multiple like subscribers or order first in first out required was order flexible. Then you try to select protocols like KMS and AMQP. That is actually legacy protocols, or HTTP REST. That's a modern protocol, right? So here what it says, key decision points. So key decision point when you're selecting to answer for a requirement. So determine the services scalability needs, the volume, and then a consumer count, fan out versus point to point pattern, and ordering, first in, first out guarantee was throughout throughput trade-offs or legacy system protocol compatibility requirement, right? So in here, you can see this one like volume is high, yes, and if it's a multiple consumers, yes, then is it a event based, then it goes to event bridge. So otherwise it goes to SNS standard, right? And if it's a multiple consumer, no. If it's a not a multiple consumer, it is a first in first out required, yes, then you go to SQS. And if it's not, then you go to SQS standard, right? And then here your volume is less, and then first in first out required, yes, and then it's a legacy. If it's a legacy, it goes to Amazon and MQ. If it's not a legacy, go to SQS P4. This is like a single customer, right? And first in, first out required, no. But if it's a multiple consumer, yes, then you go to SNS standard, right? If it's not a multiple consumer, then you go back into SQS standard, right? So let's have a look what are the use cases of these services. I'm going to stop after this slide because it's already 35 minutes, but let me explain. So SQS is standard. So simple queue service, order processing queues, image processing jobs, decoupling microservices, high throughput, at least one delivery. So that is the use case. So SQS again, first in, first out, financial transactions, user activity tracking, command processing, exactly once processing order delivery. SNS, user cases, mobile push notifications, email, SMS, alerts, pan out type messaging, multiple subscribers, thumbs up pattern, synchronous, right? Fire out and discard, sort of forget, not a discard. So event bridge and MQ. So event bridge, complex event routing, SaaS integration, or Amazon MQ for legacy, Java messaging service, advanced messaging queue protocol application, lift and shift, advanced features, protocol support. So basically, today's video we started discussing about messaging service. We discuss the key decision point and messaging services, SQS, SNS, Event Bridge, and MQ, and FIFO. And then we discuss about multiple customer or single customer. And I think it is already about more than 30 minutes today. So we're going to stop the video from here and we're going to continue from this point in next video. Until then, thank you very much.